So for this question, part A, you differentiate, okay? So the 3x squared minus 8x plus 4 comes from differentiating this. Now remember, to differentiate, you take the power, so the 3, you bring it in front, and then reduce the power by 1. So x cubed becomes 3x squared. Minus 4x squared, you take the 2, multiply it by 4, bring it in front, you get minus 8, and then the 2 goes to 1, or just x. And the 4, the x just goes to x to the 0, which would be 1, so you just have 4. Okay, so we differentiate that. Then we need to use, for part B, we need to use the fact that at the turning points, the gradient is 0. Okay, so dy by dx, which is the gradient function, equals 0. So on the graph, there are actually 2 turning points. We're only interested in one, but we're going to end up finding both. So you've got that one and that one. So the gradient function, 3x squared minus 8x plus 4, has to be equal to 0, okay, at those 2 points. The rest of the time, the gradient's going to be there it's positive, there it's negative, there it's positive, but at those 2 points, there and there, it's 0. So then I solve that's equal to 0 to find the 2 x coordinates where the gradient is 0, okay, which gives me those 2 points on the graph. So the gradient is 0 when x is 2 and x is 2 over 3. Now, they're only interested in point P. I know P must be when x is 2 because it's further along the x-axis. So that's how I work out P, okay? And then here I've just put x is 2, okay? So at P, x is 2, so I've put x is 2 into the original equation, okay? That equation to find out what the y coordinate is. Because it asks for the coordinates, it doesn't just ask for the x coordinate. And then part C, the range values when the curve has a negative gradient, you just take that from the graph. So we already know that that point's 2/3, that point's 2. The only time when the curve is going down, that's when the gradient's negative, is between those 2 points, okay, which gives me that answer.